Hello, grade 12s. Welcome back to the channel, Science Therapy, hosted by the one and only science therapist, Uabutiwa Sos Ugobela Maths. And without any further ado, let's look at this question that we have here. Okay, so we have question 8. It says, Benny is driving his speedboat at a constant speed towards a lighthouse. The foghorn from the lighthouse blows with a frequency of 180 hertz. The apparent frequency of sound heard by Benny is 188 hertz, right? Ruby, his friend, stands in front of the lighthouse as shown in the diagram below. Use the speed of sound in the air as 340 meters per second, right? Okay, so now let's assess the situation for Benny. We understand why Benny now is recording a higher frequency. Note that Benny here is moving towards the lighthouse. And whenever we see moving towards, we know that the frequency of the listener will be greater than the frequency of the source, right? Okay, so 8.1 says, state the Doppler effect in weight. Now, you already know the Doppler effect, but then let's state it, because remember, the more you get to write it, the more you get to understand it and even be at a point whereby you have already memorized it so that you can be able to write it with ease. So state the Doppler effect in weight. We say that is the change or the apparent change, right? The change in the frequency of the sound detected by the listener, because the sound source and the listener have different velocities, relative to the medium of sound propagation. Right, so that's it. So the change in the frequency of the sound source of the sound detected by the listener, because the sound source and the listener have different velocities relative to the medium of sound propagation. And that's your 8.1. Now 8.2 says, explain why Ruby perceives the same frequency of 180 hertz. Why Ruby here perceives the same frequency that is being emitted by the lighthouse. Now, we already know that it's because there is no relative motion. There is no relative motion between Ruby and the sound source. Right, so the sound source being the what? The lighthouse. The horn from the lighthouse, right? So why? Because both Ruby and the lighthouse, they are stationary. So we know that the lighthouse does not move, and Ruby here is also as well stationary. So at this point, we say the frequency of the source will be equal to the frequency of the listener. So there is no Doppler effect. There is no Doppler effect because there is no relative motion between the sound source and the listener, right?
Oh, sugar in the morning, sugar in the evening, sugar every day. Ooh, sugar. Oh, sugar. Oh, sugar, sugar, sugar. Oh, sugar in the morning, sugar in the evening. Oh, sugar. Hey, sugar. Sugar is tasty, nice.
Now, 8.3 says, how will the wavelength of the sound wave produced by the foghorn change if the frequency of the sound wave is lower than 180 hertz, right? Write down only increase, decrease, or stays the same. How will the wavelength of the sound wave produced by the foghorn change if the frequency of the sound wave is lower than? Now remember, what is the relationship between frequency and wavelength? It's inversely proportional. So if the frequency is now lower than 180 hertz, what will happen to the wavelength? Obviously, we do know that the wavelength will do what? Will increase, right? And then to explain, give a reason for your answer in question 8.3, we say frequency is inversely proportional. Frequency is inversely proportional to wavelength, right? So frequency is inversely proportional to wavelength. So F inversely proportional to wavelength, right? So that means an increase. So we can say a decrease in frequency, will result in an increase in wavelength. So there will be more wave fronts, right? So a decrease in frequency will result in an increase in wavelength. So the wave front will now be less compressed, right? Okay, now Ruby runs in the direction of the boat at a constant speed of 5 meters per second. Show by calculation that the frequency Ruby now hears is lower than 180 hertz, right? So Ruby runs in the direction, 8.5. So calculate the speed of the boat as it approaches the lighthouse. Okay, so 8.5 first. So calculate the speed of the boat as it approaches, note that. So we start with the original formula. FL is equals to V plus minus VL over V plus minus VS. Multiply that by FS. So remember, if it approaches towards, it's moving towards, so plus on the numerator and minus on the denominator. So our manipulated formula will be FL is equals to V. Remember the listener, they say calculate the speed of the boat as it approaches there. So that's what we are looking for. So the VL over what? The source, the lighthouse is stationary. So we only have V because VS will be equals to 0 meters per second. Remember, the lighthouse will not move. And then frequency of the what? Of the source. Now to then calculate that, we'll say what is the frequency of the listener? Now, are we told the frequency of the listener? Yes, 188 hertz, right? So they said it right there. They said Benny is, the apparent frequency of sound heard by Benny is 188 hertz. So that's the frequency of the listener, right? And Benny is the one on the speedboat. So 188, and then the V, what are we supposed to take it as? So they said 340 meters per second, right? So you always have to make sure of that. Sometimes they do change it. Plus VL over again 340, and then frequency of the source is 180. Now at this point, we know what to do. Just should cross multiply this. So 188, so let's just say 188 multiplied by 340, that's going to give us 63,920. And then this one here, we're just going to have 180 bracket 340 plus VL, right? So we can start by dividing both sides by this 180, right? So we just want to be clean with our math. 63,920 divided by 180. This will give us 355.11, and then is equals to 340 plus VL. Then we can take the 340 over to that side. That's 355.11 minus 340 will be equals to VL. And therefore, our velocity of the listener will now be equals to what? So that minus 340 is going to be 15.11 meters per second, right? And that's basically how you were supposed to calculate that, right? Right, so that's your 8.5.
Haya sasa, watu wapo kazini. Kazi endelee. Sisemi, najua wenyewe.
Okay, then let's go to 8.6 now. Says Ruby runs in the direction of the boat at a constant speed of 5 meters per second. Show by calculation that the frequency Ruby now hears is lower than 180 hertz. So basically, they're just saying that we must calculate the frequency of the listener. So V plus minus VL over V plus minus VS times Fs. Now, Ruby runs in the direction of the boat, right? Ruby. Let's check. So Ruby is running in that direction, meaning that relative to the sound source, Ruby is now moving away, right? Relative to the sound source, Ruby is moving away. So frequency of the listener, we don't know what it is, but then the V still remains the same. It's 340 speed of sound in air. Then, okay, so moving away, that means this is what? This is plus down here and then minus right there, right? Remember, away. And then what is the velocity of the listener? They said 5, but then we are going to say 340 minus 5 as it's moving away. Now, velocity of the source or speed of the source, it's still the lighthouse, so it's stationary. So 340, and then there we go. Frequency of the source still emits the same frequency of 180 hertz. Now you simply just grab your calculator and punch all of that. So you have a 340 minus 5 over 340 and then multiply that by 180. Let's check now. We find that our frequency is 177.35 hertz. And then yes, it is true, right? So we can see that 177.35 hertz is actually lower than 180 hertz, right? So yes, Ruby's frequency will be lower than, so we can say now, Ruby's frequency detected by Ruby or frequency heard by Ruby, frequency heard by Ruby is less than 180 hertz. There we go. So that's how you were supposed to approach these questions right here, all for a total of 16 marks. So come back to this video, play it as many times as possible, and try to understand the approach that I took into solving all these questions here. But then with all that being said, please press that like button, press that subscribe button, share the video with your friends and classmates so that they may also find assistance. Remember, do not be selfish. We are winning as a team.